This video provides an example of the conversion of solar radiation to electricity. We will use a typical residential home as our example. The first step is to determine the peak day. Here you see 1 month of electricity usage for a typical residential home during the past summer. Looking through the data, we see that July 23rd was the hottest day of the month, and it also had the highest electricity usage for the month, just under 100 kilowatts used in that day. Next, we go to the peak hour. We'll take the day and we'll look at the data in more detail, and we'll see on this particular day the load peaked at 11 a.m. in the morning, and that was a result of air conditioning load and the daily outside temperature. In that 1 hour, we used 10 kilowatt hours of electricity. So to determine the amount of solar panels required, we need to calculate the roof area of the house, and we'll focus on the south-facing roof for this house. This is a picture of a typical ranch-style home, and we're just going to make the assumption that this roof faces south. We'll use trigonometry to figure out the roof area, as the roof is on a slope, but we'll start with by taking the dimensions of the house, 30 feet wide by its length, 60 feet long, and work with the assumption that 1/2 of that roof area is south facing. So we'll sketch out a triangle representing the roof, and then we'll try to figure out here the sloped area on the south side of this house. So the first thing we do is we divide the width by 2 and calculate out, using a 5/12 roof slope, that the height is 6.25 feet. Using the identity, the C slope dimension works out to be 16.25 feet. Once we know that dimension, 16.25 feet, we can multiply that by the 60 feet long roof and come up with the area of the pitch roof. This calculation works out to be 975 square feet. A typical 180 watt solar panel is 62 inches by 32 inches. So what we'll do is we'll take 5 feet off of the roof in total to allow access around the edges of the 60-foot roof, divide it by 2.67 feet, which is the width of a panel, and we'll have 20 panels in length. Knowing the pitch distance of 16.25 feet, we could easily fit in 2 panels on top of each other, so the total number of panels are 40. Once we've calculated the total number of panels, we can determine that these panels at 180 watts will provide the total electric output of 7,200 watts or 7.2 kW. Although this number is slightly lower than the peak requirement at 11 o'clock on the 23rd of July of 10 kW, it's a good illustration of how you can use knowing the area of the house, knowing the output of a panel, knowing the incident sunlight on a given day, you can calculate the total area required and the total output of a PV solar array for a particular residential application.